Okay, in the next video we're looking at number 4, and basically what we're doing here is trying to find derivatives using the product rule and the quotient rule, but in kind of an abstract form. We don't know what f of x is, so when we need to find the derivative of f of x, that's just going to be f prime of x. So let's see how that works. So for part A, the derivative of y prime, we have a product rule here. And so our two functions are x squared and f of x. And we want 1 d2 plus 2 d1. And so 1 is just going to be x squared, and d2 is f prime of x. Since we don't know what f of x is, all we can say is that its derivative is f prime of x. So that's 1 d2 plus 2, which is f of x, d1, which is 2x. So that might be something like x squared f prime of x plus 2x times f of x, and that's the first one. Then on the second one we have a quotient rule, so it's going to be low d high, so that's x squared f prime of x minus high d low, and the derivative of the denominator is 2x over the denominator squared, which is going to be x squared quantity squared, which is x to the fourth. So simplifying a little, we get x squared f prime of x minus 2x f of x over x to the fourth, and that's the answer to part B. We'll go on to number 5. Okay, in number 5 we have a number of functions that are function compositions, and we're trying to find the derivatives using the chain rule. So we get y prime is equal to 100 times the quantity x cubed minus 1 to the 99th power. Then we still have to multiply that by the derivative of the inside function, which is 3x squared. And if we simplify a little, we'll get 300 x squared times x cubed minus 1 to the 99th power. And that's the answer to A. Okay, for part B, we have a three-wave function composition where the inside-most function is sine of theta. The middle function, if I made a mess of it, is cotangent of x, and the outside function is x squared. Something like that. So we're going to start with the outside function, which is x squared. So I just write in the different colors there the three functions that we're working with. So we're going to take a derivative of x squared, which is bring down the 2 and reduce that exponent to 1, but leaving all the insides alone. And so that becomes 2 times cotangent to the first power of sine theta. And so we found the derivative of the outside, leaving its inside alone. Now we're going to take the derivative of cotangent, which happens to be negative cosecant squared, but leaving its inside alone, which is sine theta. And then we're going to multiply that times the derivative of sine theta, which is cosine theta. And there's not a whole lot that can be done, but we can simplify a little bit. Bring out the sign, the negative sign, and any constants. So it's negative 2 times, I'll put cosine theta, times cotangent of sine theta, times cosecant squared of sine theta. And that's probably good enough. Maybe there are certain things that can be done with that, but I wouldn't worry about them at this point. Okay, for part C, first of all, I'm going to rewrite that as x squared plus x plus 1 to the negative 3/2 power. And hopefully you can see that. It's in the denominator, so the exponent is going to be negative. Square root, so it's the 1/2 power. And it's cube root. Hang on a second. No, that's completely wrong. It's negative 1/3 power. Sorry about that. So it's negative, it's the cube root in the denominator, so it's negative 1/3 power. So let's find that derivative. That's negative 1/3 times x squared plus x plus 1. Subtract 3/3, so it's negative 4/3 power times the derivative of the inside, which is 2x plus 1. And so we end up with negative 2x plus 1 over 3 times the quantity x squared plus x plus 1 to the 4/3 power.